Linear equations. Linear equations have variables to the exponent of 1, and they graph a line. So 4x plus 3y equals 6. This is a linear equation with two variables. Each one is to the first power. V equals minus 32t plus 24. This is also a linear equation with two variables. Each one is to the first power. X times y equals 150. This is not linear because of this multiplication. D equals 16t squared. This is also not linear. This will not graph a line because of this squared. This will graph a parabola. Graphing linear equations. A general linear equation is in the form of ax plus by equals c. A is the coefficient of x, b is the coefficient of y, and c is the constant term. A solution to an equation is a pair of numbers, an ordered pair, one for each variable, that when substituted into the equation makes it true. As an example, if I have y equals 3x plus 2, and I want to know which one of these ordered pairs is a solution, either 1, 7 or 2, 8, I need to plug them in and substitute them for the variables x, y, and see if they're true. So when I take the first ordered pair, 1, 7, x is a 1, y is a 7, x is in the first position, y is in the second position. I make the substitution. So for instead of a y, I put a 7 equals 3. Instead of x, I put a 1. 3 times 1 plus 2. So 7 equals 3 plus 2. Does 7 equal 5? No. So that one is not a solution. Let's try the other one, 2, 8. So 2, 8, x is a 2, y is a 8. Again, plugging in, substituting into the equation. 8 equals 3 times 2 plus 2. Does 8 equal 6 plus 2? Does 8 equal 8? Yes, this is true. So 2, 8 is a solution. What does that mean on a graph? The same equation, y equals 3x plus 2, is in y-intercept slope form, slope-intercept form. So the y-intercept is here, 0, 2. The slope is a 3, right here, slope. So first I'm going to do start with the ordered pair 0, 2. So 0, 2, that's the y-intercept. And then I'm going to graph the slope. So I'm going to, since the slope is 3, I'm going to go up 3 and right 1 from the y-intercept. So from the y-intercept, I go up 3, right 1, up 3, right 1. That puts me right here. So you can see that the ordered pair 2, 8 is on the graph. So over 2, up 8, that's on the graph. 1, 7, however, 1 over 1, up 7, that is not on the graph. That's why it's not a solution. So in order for something to be a solution graphically, it has to be on the graph itself. So a solution to an equation will be on the line that is graphed. It also will make the equation true when it's substituted into the variable. So graphing is a little tedious, so it's easier to be able to do it mathematically. You just need to plug it in. A review on slope. Slope is m for the coefficient or for the variable that represents it. This can be found by using two ordered pairs. X1, y1, x2, y2. So slope is equal to y2 minus y1 divided by x2 minus x1. So I'm going to use just different ordered pairs. So 2, 8 and 1, 5. So 2, 8 was actually on the graph that I graphed over here. And 1, 5 is also on the graph. I just pulled it off by looking at it after I graphed it. So 1, 1, 2, 3, 1, 1, 2, 3, 4, 5, right here, 1, 5. So I take 2, 8, 1, 5, and I'm going to find the slope, even though I know the slope because the slope is right here when it's in slope-intercept form. But let's just verify it. So I randomly ordered my pairs, x1, y1, x2, y2. So y2 minus y1, so it's going to be 5 minus 8, 5 minus 8, 1 minus 2, 1 minus 2. So 5 minus 8 is minus 3, 1 minus 2 is minus 1, so minus 3 divided by minus 1 is 3. So yes, the slope is 3. Let's say I ordered the pairs differently. Instead of calling the first one x1, y1, I call it x2, y2, and I call the second one x1, y1. So here it is, x2, y2, x1, y1. I'm still using the same formula, y2 minus y1, so I just have to make sure I grab the right ones. So y2 is 8 minus 5, so 8 minus 5. x2 is 2, 2 minus 1, so 2 minus 1. 8 minus 5 is 3, 2 minus 1 is 1, so 3 over 1 is 3. Notice how I get the same exact thing. So it does not matter how I order these pairs, I get the right slope. However, let's say I was being sloppy and I ordered them differently. You cannot mix up the ordered pairs, meaning you can't call the first one x1 and the second one y2. They have to match. And I mean, it's not like you're going to write this down because obviously you can see that it's not correct. But what happens is if you don't label them, you may grab the wrong ones. So let's see what happens when that works. y2 is an 8, so 8 minus 5. And now x2 I labeled over here, so 1 minus 2. So 8 minus 5 is 3, 1 minus 2 is minus 1. I do get that 3, but just look at the sign. The sign ends up being wrong, and that's not true. So just be very consistent when you're labeling the ordered pairs. So back to the slope-intercept form, y equals mx plus b. B is the y-intercept, 0 comma b, or you can find it by making x equal to 0 and solving the equation. M is the slope, right here, and to find the x-intercept, you make y equal to 0 and solve. So when the equation is in the slope-intercept form, the only thing you can pull off of it is the y-intercept and the slope. You do not get the x-intercept. You actually have to solve it to get the x-intercept. So let's take this equation here. 2x plus 4y equals 8. And this time I want to graph it by the intercepts. Notice it's not in the slope-intercept form. I would actually have to move this equation around to get it into the slope-intercept form. But I'm going to calculate the intercepts. So when the equation is in this form, I cannot see the slope, I cannot see the y-intercept, and I can't see the x-intercept. So I have to do some math. So for the find the y-intercept, I make x equal to 0, which means you just put a 0 in for x and solve it for y. So 2 times 0 plus 4 times y equals 8. That's 4y equals 8. Divide by 4. 4y divided by 4, 8 divided by 4. I get y equals 2. So here the y-intercept is 0, 2. Now let's calculate the x-intercept. The x-intercept, I have to make y equal to 0. So here's my y. I'm just going to put a 0 right there. So 2x plus 4 times 0 equals 8. 2x equals 8. Divide by 2. X is a 4. So my x-intercept is 4, 0. Again, I calculated the 4. I put in a y of 0. For the y-intercept, I calculated the 2 for y, and I put in a 0 for x. So if I take those two ordered pairs and graph it, let's see, 2, 0, or sorry, 0, 2, 0, 2 is right here. And 4, 0 is right here. So when I graph those 2 points, I can connect the dots, and there's my line. Notice how it's leaning left. This means it has a negative slope, but I can't see that from here unless I rewrite that equation, which I did on the following example. I have the exact same equation, 2x plus 4y equals 8. Now this time I'm going to put it into slope-intercept form, meaning I'm going to solve it for y. So to solve this for y, I subtract 2x from both sides. So I get 4y equals minus 2x plus 8. Notice I put the minus 2 first after the equal sign, even though the 8 is here after the equal sign. I want to make sure I look at the correct y-intercept and slope. Divide by 4. So divide everything by 4. So I get y equals minus 1/2. So 2/4 is a half. Minus 1/2 x plus 2. So my y-intercept is here because it's in slope-intercept form. So it's 0, 2. And that is what I calculated here, 0, 2. And my slope right here is a minus 1/2. So I can put the minus with the 1 or I can put the minus with the 2. There's only one negative when you have a negative slope. It either goes on the top number or the bottom number. And the only reason you need to put it someplace is because you have to know how to move. So if I put it with the minus 1, it means I go down 1, right 2. If I put it with the minus 2, it means I go up 1, left 2. So basically a negative slope has one negative direction. Slope is negative. You cannot see the x-intercept from the slope-intercept form. So again, I can't see the x-intercept, but I do get a lot of information. I get the y-intercept and I get the slope. So if I'm graphing this, again, I start at the y-intercept, 0, 2. So that's here, 0, 2. And I want to move the slope. I'm going to use this one. I'm going to go down 1 and right 2. So from the y-intercept right here, I go down 1, right 2. And I can do it again. Down 1, right 2. And there's another point. I could keep going and getting all those points. But I stopped here because I wanted to point out there's the x-intercept. So the x-intercept is where it crosses the x-axis. And now I can pull this off the graph. And that ordered pair is 4, 0. And again, that is what I had calculated here for the x-intercept, 4, 0. But in this case, when I use the equation in the slope-intercept form, I was able to pick off the y-intercept from the graph. Sometimes it's not that easy. Sometimes it doesn't cross on a line and you have to kind of estimate it unless you did it on a calculator and you can move the cursor over and see what it is. Now I'm going to take another example and just find the slope. I put some negatives in here so you can review how you do the double negatives. So I just randomly picked minus 2, minus 1, and 4, 3. So I labeled them x1, y1, x2, y2, and now I'm going to plug them in. So x2, so 3 minus x1, or y1 minus 1, so y2 minus y1, x2 minus x1, so 4 minus the minus 2. So that ends up being 3 plus 1, 4 plus 2, so it's 4 over 6, and reducing that, I get 2/3.